Good morning, TechCrunch. My name is Jeff Mills. I am the president at iMerit, where for the past decade, we've been at the forefront of expert data for AI. I am joined up here, not with just a partner, but with my dear friend, Fahad Khan. Fahad, it would be great for you to introduce yourself to the group today, but maybe talk a little bit about how Blue River, a Khosla-founded startup in Silicon Valley, has integrated with a company that was founded in 1837.
Sure. Thanks, Jeff. First of all, pretty excited to be here. Amazing opportunity. Just a little bit about myself. I'm actually the head of product management for a platform that runs data, machine learning, and robotics. Jeff, like you said, Blue River, which was acquired by John Deere back in 2017, it was almost like a match made in heaven, because Blue River sits at the critical intersection of mission, machine, and model. So John Deere had all the hardware. Blue River had all the software. Blue River had all the talent. So the coming together of these two entities was, pretty amazing. In short, going from the most trusted equipment manufacturing company to a company that is leading with technology and intelligence, that's pretty amazing. At the end of the day, if you look at what we have been able to do, our most popular product is See and Spray. Sounds pretty simple to understand, and it is really simple if you think about it. If we see a weed, we spray it. Sounds simple enough. And we try and save the amount of pesticides that are being used. We have been able to do that using computer vision-based machine learning. And at the same time, we're also now entering into autonomy. But the most exciting part for me, is not just about bringing technology to agriculture, is about augmenting the farmer's intuition with intelligence.
And they're a little smarter than people think, right? These guys are actually experts in the field, and you've brought AI from the lab into the field. You guys have really become a robotics company over the last several years. Talk a bit about how mission critical this work is. And at iMerit, we talk about mission critical AI a lot, where the penalty for failure is significant.
Yeah.
It's not lightweight AI. This isn't just a product recommendation engine that maybe recommended you a rom-com on accident. This is something where when the AI fails, the penalty is significant. Maybe talk a little bit about how the farmers are working with you guys on that, and how you guys are seeing that literally in the field.
Yeah, so just so you know, the stakes in agriculture for AI and autonomy are almost existential. Let's say, when we are operating in the digital world, if you make a wrong prediction, the most that happens is a few lost clicks, right?
Right.
But if we make a wrong prediction in the field, that means lost yield. That is someone's livelihood. That is someone's entire output for the season. So we treat everything that we do as mission critical safety systems. We really build a ton of resiliency, redundancy, and most importantly, a number of our steps are validated by humans. So all of our machine learning loops, at every stage, whether that's the training stage, data set accumulation, validation, we work with the appropriate experts to incorporate their feedback. And the biggest thing is, it's not just these agronomists who are working with us, it's also, the farmers' observations that we are taking into account. I would say, in short, we get maybe one chance with each farmer. If we mess that up, there's no going back. So a lot of this is based on trust. And trust in this, especially in agriculture, it's earned, not assumed, just because you are a technology company.
And I think when you bring about the human in the loop layer, what's interesting on that is, I think a lot of people think of it as, again, like crowdsourced, basic kind of annotators. But we're talking about agronomists here. We're talking about experts in the loop here, not just human in the loop. Talk a little bit about maybe why the expertise is so important in the people who are doing that work, and then maybe how that integrates into your stack, the importance of kind of those two things working together. Because I think a lot of people misinterpret that human in the loop is outside of the stack, where in this case it's very much integrated.
Yeah, absolutely. You're absolutely right. It's actually very much integrated. But before I talk about who these experts are, just to give you an idea, the conditions that we work with are extremely rugged. So think about it this way. You know, whether it's the weather, it might be raining one day, it might be, there might be thunderstorms, it might be sunny, it might be shiny. You know, we might go from one crop which is at a certain stage in its life cycle to a different stage. There's so many variables, and you know, light and dust does not spare us either. So just so you can understand, there's only so much we can do when it comes to model training, model fine-tuning, all that good stuff. At the end of the day, we really need experts, and these are people who have PhDs in agronomy. And they are the ones who are telling us that, hey, look, this is how the crop should look. Sometimes it's impossible to identify a weed from a crop. Certain types of weed, they do a pretty good job in covering the crop, and you have no idea, like, hey, is this a crop? Is this a weed? Like, if you ask me, I wouldn't know. If you ask my 50 plus ML engineers, they wouldn't know. So incorporating this intelligence, incorporating this knowledge is so much important. So the way that it works for us at the highest level, it's a loop. So all the way from collecting data from the machine to processing it in the cloud, to finding all the edge cases where we might not be performing like how we should be performing, whether that's due to dust, whether that's due to light glare, whether it's due to different terrain conditions. We make sure that human input is integrated into each one of these steps. Right. And it doesn't end at creating the right data set. It doesn't end at training the data set. It also, there's this isn't a continuously iterative process. So long story short, when we run these machines in the field, we are continuously looking at how to evaluate or model performance against what we are seeing in the field. And when we are doing the model evaluation, humans are essential in getting this done. In short, the way that our model pipelines work, they are really based on they incorporate both the real farmer observations and the experts who are telling us, hey, what should it really look like?
Sure.
In short, a lot of retraining happening, a lot of reinforcement learning happening. A lot of people think that you can just do it based on data, but what we have realized, doing over hundreds of millions of acres in autonomous farming, that's not true. You really need the human feedback in there.
And that's actually grown too, right? You guys aren't just doing this in like Iowa anymore, right? I mean, like you guys are doing this all around the world. Maybe talk a little bit about how that kind of expansion, right, is changing the way you look at this. And then one of the things that you've talked to me about before in kind of great detail that I think would be interesting to the group here is the types of models, right? Because some of these are very like specific models, and then some of these are like custom models, right? So you guys are jumping between like vertically specific models to very custom models to solve all these like different types of problems that you guys keep running into. And I'm imagining when you guys start doing this in all these other countries that you guys are starting to move into, that's just gonna grow.
Yeah, absolutely. So, the way that we think about models, we categorize them into three main buckets. The first one are obviously your generic models. So these are your ChatGPT, LLM types, which can be helpful in summarization of certain things that we are researching. Then you have your vertical models, which, are very specific to doing a very specific task. And for every crop that we are able to work with, we have a vertical model for that. And then once you get into autonomy, then you have your custom models or the fine-grained models, where obviously you start with something that is available readily, but you train it to solve for cases that are relevant to you. So at the highest level, when I started at Blue River, we used to only have two models for automation. They were just perception and depth. In simple words explained, how far the object is and what is the object. That's it. Nothing too significant about it, right? But in short, what we realized that one model rarely fits the bill.
Right.
You have to combine them together to get the most output. Just to give you an idea, a tractor can move anywhere between 20 to 30 miles an hour, and as they're making a pass, we get less than a few milliseconds to make a decision whether should we spray, should we not spray. And to make that happen, things like latency, things like making sure that our model hits it with the right accuracy is so much important, because if you don't get the pass right, that could be a few $1,000s.
Mission critical.
Yeah, absolutely. It could be a few $1,000s that are lost out there. So, but yeah, we have models per crop. We have models for certain regions. But at the end of the day, they do get consolidated into a perception and a depth model. Yeah.
And then, multimodal starting to become a big topic, right? People think you're just using probably image data right now, but I know better. Gen AI is definitely becoming part of this now. Synthetic data is becoming a big part of this now. Maybe kind of talk a little bit about the kind of evolution of that piece, from just kind of starting by looking at what are the objects and what is the distance, to kind of how you're now integrating multimodal and synthetic data and these different properties.
Yeah, so just to give you an idea, right? Multimodality has been key for us. So long story short over there is, we started with purely cameras.
Right.
And these were specialized cameras that we worked with a hardware manufacturer to build, because these cameras needed to handle dust. If you have ever seen a tractor in the field, when the tractor runs, there's a huge dust cloud behind it. And now you have this camera, right, that is trying to assess whether it's a crop or a weed or is an object in front of me.
AI in the dust.
AI in the dust. It's insane. Like, if you ever get a chance, go to one of these fields, you will see exactly what I mean. But we realized that, okay, maybe cameras are not enough by themselves. We need another modality. So we started to look at radars. We started to look at LiDARs. And what we realized is, there are obviously pros and cons of going to a multi-model, multi-models, but the thing is, we realized it actually gave autonomy more resilience. It was easier for us to identify objects in more challenging conditions than it would be if we stick with a single modality. That has been one of our key learnings, I would say. If we could use every signal from every modality, that just gives a better chance to make sure our predictions are as accurate as they can be, because, like we said again, these predictions are pretty mission critical.
Yeah, and at a conference like this, I think there's a lot of companies who are building right now that want to build to scale. They want to deploy these models. They want to deploy them in production. You've been taking kind of, again, models from the lab, bring them into the physical world, designing physical AI systems, pushing them out there. Why don't you talk a little bit about kind of key learnings, best practices? I mean, I know one key learning that we discovered at one point, but would love for you to share some of that, because I think that you guys just have this wealth of knowledge by going through these steps, and you guys have really taken it into production. You guys have really taken it into the field, quite literally. Talk about what you guys have learned, because I think that would really help some of the people here.
Yeah, so we actually learned 3 things. I think I can summarize them for you. The first thing we learned is that the field data that is out there, it's extremely messy. We already talked a little bit about it, the dust, the lighting, all that, good stuff, right? So obviously we have to make sure that we build robust systems through having data sets that are diverse,
right?
Having data sets that captures the right climate conditions, having data sets that captures all stages of growth for a crop. So that's one thing. And the second thing also we covered a little bit, which was about using all the modalities from all different types of equipment that we can get, everything from a camera to a radar, LiDAR. But I think the most significant learning that I had personally was we have to design for the farmers, for the humans, because there is Nothing. You can take Gen AI to generate a lot of synthetic data, and we have been doing that. Don't get me wrong. We have been doing a ton of this, right? But what you have to realize, it only goes so far. There are so many variables in the automation and the autonomy department that it's insane. And here's the other thing too. When you have these models running, one thing that Gen AI hasn't been able to do, it's great for improving labeling efficiency.
Right.
It's great for improving search. It's great for doing a lot of things, but it's not great at explaining why a model took a certain decision. How did they arrive at the certain decision? So at the core of our learning, what we are really at is if we can combine precision agriculture with precision AI, powered by human context. So it just ties back into what we were speaking before. Because at the end of the day, trust is what is completely essential in the world of physical AI. And in short, I would just say transparency of why a decision was made, that's critical. If you have that transparency, that will build trust, and trust will build adoption. And the way we do that at John Deere is we have this amazing Ops AI center where any of our farmers can come in, they can take a look at exactly what the machines were thinking. Literally, we describe and break it down in terms of see, sense, and act. You can literally see what the machine saw. You can literally see the thought process the machine went through. And at the end, you can literally see what were the actions and what were the probabilities that the machine was deciding against, and go from there.
So our mission at iMerit is to really help develop the high quality ground truth data, right, that goes in to power these models. And continue to monitor them as they go into production. Talk a little bit about the data sets in the beginning, maybe, that we might have put out there in the field and stuff like that, and the kinds of data sets you've had to add on top of as production continued, because maybe what was thought to be needed in the very beginning may not have been exactly what's needed, and I think every company in the world can experience that, yeah?
Yeah, for sure. So I will share a very fun example. So when we were putting our first See and Spray tractor out there, we thought our models, were amazing. We thought they, literally for lack of a better word, we thought they were the shit, when it comes to crops, And then we realized that, oh, okay, so we created all these models and we sell our first machine. These models were trained maybe at the start of the year, maybe January, February. If the first machine goes into production around maybe June, July, and the machine doesn't work, the model doesn't work, and we are like, whoa, what's going on here? And what it was at that time we didn't realize that we have to collect data at each stage of the crop growth. So the crop can look different in January versus in June.
They should have bought the tractor earlier.
I know they should have bought the robot
earlier.
I know they should have bought the tractor earlier. That's what my ML engineer said too. The commercial team didn't agree, but we'll see. But yeah, so things like that. So that really helped us. That really changed our mindset. It was not just about improving the iteration speed of releasing new models, tackling all sorts of edge conditions, but also taking into account all these experts that you were talking about, taking into account the agriculture, the biological life cycle, and aligning that with it. That's pretty hard to do so, but yeah.
So we've got a minute left. I can't believe that time went by that fast. Talk a little bit about what's next for Fahad, what's next for Deere & Company.
Yeah, honestly, just pretty excited to continue to scale this initiative. Hopefully, by 2030, a significant percentage of our tractors will be autonomous. Not just tractors. Most people only know John Deere as an agriculture company, but we are into forestry, construction. So you will see autonomy in pretty much every domain that we actually have. In addition to this, in addition to doing precision agriculture, autonomy, we are also, experimenting with what we call prescriptive AI. So hopefully, the idea would be to help farmers' intuition with some more intelligence. So what should they plant? When they should plant? What techniques should they actually use? So literally like becoming even a more closer friend with the farmers, with the operators that we actually have, and just continue this growth.
I love it. We have a little table out here if anybody wants to stop by and ask Fahad any questions. We'll be over there for the next 10 minutes or so. Fahad, thanks so much for joining us, man.
Thanks so
This is
much for
awesome.
the opportunity.
The great Fahad Khan, everybody.
Thank you.